When it comes to analyzing circuits that are wired in parallel, the concepts are slightly different. When we refer to the term parallel, that basically just means that the elements are placed in different what we call legs or pathways of the circuit. So you can see in the example here, this would be a circuit that has two resistors wired in parallel. If you remember in series, if I'm an electron leaving one terminal of the battery, I only have one pathway to get from the positive to the negative terminal. However, in a parallel, it allows me options. So when I hit this junction here, I can decide to either go through this leg or through this leg, but regardless of which one I choose, I will only have to go through one of these two resistors. So circuits that have elements wired in series, an electron has to go through every single element, whereas circuits wired in parallel, you have options. You want to think of it as like a toll booth. If you had a bunch of toll booths lined up one right after the other or in series, that would be very annoying. You get more traffic. The speed at which those cars would travel would be slower because each individual person has to stop at each individual toll booth. Everyone behind them has to wait. Parallel is a little bit more efficient in terms of how much current can pass through, because if I get to this junction and it seems like this one has a lot of traffic, so to say, well, I can just jump over here into this leg. So parallel gives these electrons more options and generally allows more current to flow through because of the additional options. In terms of analyzing a parallel circuit, regards to the concepts, they're fairly similar to what we looked at when we looked at the series circuits. However, there's slight differences. Some of the key concepts include the same voltage drop. That's something that applies to any circuit. By going through a resistor, an electron or a charge is going to lose some voltage. It's going to spend the voltage, so to say, to get through that resistor. And again, all the voltage must be spent when traveling through that circuit. If I have 18 volts to spend, well, whether I go through leg 1 to get to the other terminal, leg 2, or leg 3, no matter what I choose, I have to spend all of that voltage. So despite the fact that they may have different resistances, you can see here, since I'm only going through one resistor in each case, I would have to spend all 18 volts because I have to spend all my voltage. Where the difference comes in regarding parallel and series comes in what's happening with the current. If this was series, if we ignore these two over here, we just have one resistor. If this is series, whatever current leaves this battery will have to travel through that resistor. It's like saying you have two buildings, you have the school and your house, you'd like to leave school and go home. If you only have one roadway, that means every car that leaves the school will have to travel the same road to get to your house. Well, in a parallel circuit, it's different. I have other streets, so to say. I have other options. So while, 10 cars may leave this region or this school, well, I don't know how many will necessarily go on this road, or this road. That's why I've called them I1, I2, and I3, because the current can be different. I can have different numbers of electrons, different number of charges in each branch. The only thing I do know is when I add these three up, it will have to add to this total, because whatever total entered these three branches must be the same that exit the three branches. So that's the big difference. Series, the current is the same everywhere. Parallel, things get a little bit trickier because each individual leg could have a different amount of current. It really comes down to what these resistors are and how much resistance in each branch is present. If we take a look, as I said previously, no matter which of these pathways is chosen by an electron, you'll notice you only go through one resistor. So I know that I'm going to drop voltage across that resistor, and I know that all my voltage must be spent. So if I realize that and combine those two, well, if I go through pathway 1 or pathway 2 or pathway 3, I pass through one resistor. My voltage will drop across every resistor I travel, and my voltage must always equal to 0 at the end. Because I just have one resistor, you can hopefully realize that all the voltage drops across these three will have to be 18 volts, because I only have one option. All right, so if you take a look at this example, I'd like you in your notes draw a circuit diagram that incorporates the following. One 8 ohm resistor, one 3 ohm resistor, a switch that controls the 8 ohm resistor only and will not have an effect on the 3 ohm resistor. This whole thing should be connected to a 120 volt power supply, and I would like all of these elements wired in parallel. And then I'd also like you to figure out what the voltage drop across the 3 ohm resistor is. All right, so if you can pause the video now, once you finish this problem, I'll have the solution posted at the end of this video. Once you're square with that, you can go ahead and look at the assignment for today.